I'm pretty sure that YEESMA motor is gonna have its success in this particular application because it's a unique topology which achieves the sustainability goals in this segment.
Hi everyone, I'm Yuqing. Today we are focusing on a unique and patent technology, rare earth-free electric motor. With the goal to achieve the low cost and sustainable solution, we are honored to welcome the Professor Nuzzo. He and his team are working on with YEESMA on testing and building on the YEESMA's technology. So, Professor Nuzzo, it's a pleasure to have you here.
It's my pleasure, Cassie, to be here today. Indeed, we are working with YEESMA on this very interesting project, a unique motor topology. Also, at the University of Modern Reggio Emilia, we are prioritizing motor designs with reduced rare earth usage and usage of alternative materials for sustainability-oriented designs.
Before we dive into this cooperation, could you tell us a bit more about your background and your current research at Unimore?
Sure. I am a professor of electric drives and electrical machines at the University of Modern Reggio Emilia within the Department of Engineering Enzo Ferrari. My main research interests are the analysis, the modeling and the optimizations of electrical machines for both industrial and traction applications based on sustainability and reliability design approaches for both radial flux and axial flux synchronous drives.
That's really impressive. And in terms of your team at Unimore, you guys also work closely with a company to turn the lab research into the real product prototypes?
Yes, hardware proof of concept is one of our goals. Thanks to the geographical position of Modena, that is in the Italian Motor Valley, we have a strict collaboration with the companies which are in our territory. And yes, usually we work pretty close in collaboration with those companies, prototyping some proof of concept, and we test them for validation purposes.
That's really good because this idea of the turning research into the reality is also really aligns with the way you have done with YEESMA. So could you tell us more specifically about this cooperation and the key focus point?
Sure. So YEESMA has basically designed this type of a new motor topology, which is indeed new because contrary to the state-of-the-art PM axial flux machines, it includes two one-field rotors. And this is the innovative part. Okay. And for what concerns our collaboration within this YEESMA project, basically we focused on the structural analysis of this type of machines because the peculiar structures of the rotors brings new challenges, new structural challenges to the design. This means that we need to run very accurate 3D structural simulations, whereas the second part of this collaboration is prototyping and testing. This is already currently ongoing. The prototype is there, is ready, and is currently on our laboratory test bench for testing.
That's really good actually, because this is not just like an idealistic design state on the CAD, it's real and it runs. And how would you evaluate this prototype's potential, especially from the perspective of feasibility?
Yeah, that's a very good point indeed, Cassie. From a feasibility point of view, the technology is slightly beyond is slightly late compared to the radial flux counterpart. Okay. On the other hand, compared to the PM counterparts of axial flux machines, this type of machine seems to be okay. We didn't face too many challenges in the prototyping. We had in mind the manufacturability during the process, taking also into account potential serious production context. Together with YEESMA, we have already identified what could be the manufacturing shortcomings of this technology, together with their respective solutions. So we are pretty confident that the advances in the manufacturing of electrical machines in general are leading to the practical feasibility of axial flux machines, even though these are equipped with one-field rotors.
Sounds really amazing, but was it harder to control, in comparison to the state-of-the-art motors like the IPM?
That's also a very good question, thank you. Basically, the testing is at its preliminary phase. We have done all the no-load testing. For what concerns the load testing, we are there, we are almost ready to go. We have tested some overload capability of the machine, but we will discuss it later probably. For what concerns your direct question regarding the comparison, that's true. The wound-field rotors are slightly difficult to control because you have an additional quantity to control, which is the excitation current. On the other hand, the fact of regulating this excitation current can allow you a unity power factor control during the flux weakening and the constant power operation, allowing for a better inverter utilization, for example.
That's really good. But do we get any concrete testing result from this round of testing, like the peak of torque or power or efficiency?
Yeah, so as I was mentioning before, we are currently testing the machine. The no-load tests have been completed. The match between experimental and simulation results are very good, are excellent. So we are very happy with this preliminary phase of testing. For what concerns the load testing, we are in the process of testing the efficiency of the machine, the thermal behavior of the machine, but we have done some preliminary tests to check whether this machine can achieve the desired and targeted peak power and peak torque. With this preliminary phase, we have achieved about 20 Newton meters of peak torque with 5.5 kilowatt. Which is great for such type of application, which is the 2 or 3 wheelers, electric wheelers, and also of course the next phase, as I told you, is to test the efficiency in the specific point, which are the most used points within the driving cycle of these 2 or 3 wheelers.
That definitely is a highlight for the industry, yeah. And during this cooperation with YEESMA, was there anything like you will impress you, like the design thinking or cooperation experience?
I can mention that working with the YEESMA team was great because they are very flexible. They are very open-minded, and this helps a lot, especially when you come from an academic world where you think about research typically or prototyping, whereas of course having an open mind but taking into consideration practical feasibility and manufacturability and production of such type of machines is of course it's very great. Okay, it's great. So yeah, I can tell that they are very open-minded to challenges. And this helps a lot in finding a convergence point between the academic world and the industrial one.
It's our pleasure to work with you as well. And if you have to summarize this cooperation with YEESMA into one sentence, what would it be?
Oh, that's a difficult question. I'd say that it has been the right convergence between let's say the academic research approach and the industrial pragmatism. I'm pretty sure that YEESMA motor is gonna have its success in this particular application because it's a unique topology which achieves the sustainability goals in this segment.
Thank you so much, Professor Nuzzo, for your sharing, because we are also looking forward to more breakthrough from Unimore and YEESMA. So thank you again.
Thank you, Cassie. It was my pleasure to be here. There is much more to come.